Hi all, let's start Maths, grade 11, chapter 2. Chapter name is Relations and Functions, subtopic Cartesian products of sets. Learning objectives. After this session, learners will be able to define the concept of Cartesian product, apply the concept of Cartesian product to solve related problems. Introduction to relations and functions. In our daily life, we come across many patterns that characterize relations such as a brother and sister, father and son, teacher and student. In mathematics also, we come across many relations such as a number m is less than number n and line L is parallel to line m. Set A is subset of set B. In all this, we notice that a relation involves pair of objects in certain order. So, in sets and in relations, we will call that one as Cartesian products of sets. Suppose A is set of two colors and B is set of three objects. So, A colors are red and blue. Objects are here. Bag stands for B here and coat. C stands for coat and S stands for shirt. So let us represent this in the ladder form here. Colors are represented horizontally and these objects are represented vertically. Then if we ask that how many pairs of colored objects can be made from these two sets, the answer is 6. They are red and B, so red bag and red and C, red coat and red and S, red shirt. Similarly, blue bag, blue coat and blue shirt. So there are 6 distinct pairs and they are red B, red C, red S, blue B, blue C, blue S. Let us see definition of this Cartesian product. Given two non-empty sets P and Q, the Cartesian product of P into Q is a set of all ordered pairs of element from P and Q. That is, P into Q is equals to set with the elements small p comma q, where small p belongs to set P and small q belongs to set Q. Let us see exercise 2.1 question number 1. If x by 3 plus 1 comma y minus 2 by 3 is equals to 5 by 3 comma 1 by 3, find the values of x and y. Solution. Given x by 3 plus 1 comma y minus 2 by 3 is equals to 5 by 3 comma 1 by 3. Now, as the ordered pairs are equal, the corresponding element should be equal. That is, first element of the first set should be equal to the first element of the second set. Similarly, second element of the first set should be equal to the second element of the second set. Therefore, x by 3 plus 1 is equals to 5 by 3 and y minus 2 by 3 is equals to 1 by 3. Let us solve for x. X by 3 is equals to 5 by 3 minus 1. Let us take LCM. So LCM is 3. So we are going to get x by 3 is equals to 5 minus 3 divided by 3. 5 minus 3 is 2. So x by 3 is equals to 2 by 3. Upon cancelling 3 and 3 in both the denominators, so we'll get x value as 2. Now let us solve for y. Y minus 2 by 3 is equal to 1 by 3. So let us transpose minus 2 by 3 to the right hand side. So we'll consider that y is equals to 1 by 3 plus 2 by 3. By taking LCM as a 3, we are going to get y is equals to 3 by 3. That is, y is equals to 1. Therefore, x is equals to 2 and y is equals to 1. Let us see question number 2. If the set A has 3 elements and set B has the elements 3, 4, 5, then find the number of elements in A into B. Solution. Given set A has 3 elements and set B has elements as a 3, 4, 5. So, number of elements in set B are 3. So, the number of elements in the Cartesian product A into B is number of elements in set A into number of elements in set B. Therefore, the total number of elements is 3 into 3, that is 9. 3 3 is 9. Therefore, the number of elements in A into B is 9. Let us see question number 3. If G is a set with its elements 7 and 8 and H is a set with elements 5, 4, 2, find G into H and H into G. Solution. Given set G and set H, the Cartesian product of set P and Q is given as a P into Q such that small p and small q, which is a P belongs to the set P and small q belongs to set Q. Therefore, G into H is can be written as 7, 8 into 5, 4, 2. Now, 7, 5, 7, 4, 7, 2, 8, 5, 8, 4, 8, 2 is a Cartesian product of G and H. Let us see H and G. So H and G we can write it as a 5, 4, 2 into 7 and 8. Therefore, we are going to get 5, 7, 5, 8, 4, 7, 4, 8, 2, 7, 2, 8 are the elements of the H and C. Let us see question number 4. State whether each of the following statements are true or false. If the statement is false, rewrite the given statement correctly. First statement is, if P is equals to set with the elements M, N and Q with a set with the elements N, M, then Cartesian product of P and Q is set with the elements M, N, N, N. Solution. First statement is, if P is with the elements M and N, Q is with N and M, then P into Q is Mn and N, N is false. The correct statement is, if P is equals to with the element M and N, Q is equals to N and M, then Cartesian product of P and Q is, it should consist of the elements M, N, M, N, N. Because when you are multiplying Mn, thenMm, then Nn, then Nm. So in the statement given, M and M is missing and N and M also, these two elements are missing. Therefore, this is a correct statement. Second statement, if N were two non-empty sets, then A into B is a non-empty set of ordered pairs x, y such that x belongs to A and y belongs to B. The statement, if N were non-empty sets, then A into B is a non-empty set of ordered pairs x, y such that x belongs to A and y belongs to B is true, because when we are multiplying the two sets with this non-empty, both as non-empty sets, then the resultant should be not be an empty set. So this is a non-empty set. Third statement, if A is having element with a 1, 2 and B is having 3 and 4, then A into B intersection an empty set is true, because whenever we are taking this intersection with an empty set is always an empty set. So when we are multiplying any set with us, an empty set is always empty set. Therefore, this statement is true. Let us see question number 5. If A is equals to -1 and 1, then find A into A. Solution. Given A is having the elements -1 and 1, then A into A product of -1 and 1 with the same set, -1 and 1. Therefore, we are going to get this values as -1, -1, -1, 1, 1, -1, 1, 1. Then A into A. So we can multiply this A with this product of these elements. So that is, this A we are representing, this A into A we are representing with a -1, -1, -1, 1, 1, -1, 1, 1. So when we are multiplying that one, we are going to get 8 elements with this -1, -1, -1, -1, -1, -1, 1, -1, 1, -1, -1, 1, 1, 1, -1, 1, 1, -1, 1, 1, 1, -1, 1, 1, 1. Let us see question number 6. If A into B is a set with elements A, x, A, y, B, x, B, y, then find A and B. Solution. Given A into B is set with elements A, x, A, y, B, x, B, y. The Cartesian product of set P and Q is given as P into Q set with this elements small p and small q, where small p belongs to set P and Q belongs to set Q. Considering A into B, then set A is all first elements and set B is set of all second elements. So by observing here now, if we mark that one, set A is considered all the first elements. So what are the elements here? A and B. Therefore, set A is consists of the elements A, B. Now let us see set B. Set B consists of all the second elements. If we observe, there is a x and y. Therefore, set B is x, y. Therefore, A is equals to set A is having the elements A, B and set B is having the elements x, y. Let us see question number 7. Let A is set with element 1, 2. B is a set with elements 1, 2, 3, 4. C set with element 5, 6 and D is set with 5, 6, 7, 8. We need to verify A into B intersection C is equals to A into B intersection A into C. And second subtopic, A into C is subset of B into D. Solution. Given A is equals to 1, 2, B is 1, 2, 3, 4, C 5, 6, D 5, 6, 7, 8. Now let us see first one. A into B intersection C can be written as A into B value is here 1, 2, 3, 4 intersection 5, 6. So there is no common element between this A and B and C. Therefore, this we are going to get as an empty set. Therefore, A is 1, 2 multiplied with an empty set. The resultant is an empty set. Here we need to note down there, multiplying any set with this an empty set is always an empty set. Therefore, A into B intersection C is an empty set. Let us make this as equation 1. Now, let us solve for the second one on the right hand side. A into B intersection A into C. So, A into B is 1, 2 with multiplied with the 1, 2, 3, 4 intersection 1, 2 with multiplied with the 5, 6. So, we are going to get 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4 intersection with 1, 5, 1, 6, 2, 5, 2, 6. If we observe, no element between this is common from these two. Therefore, the intersection of this will be an empty set. Therefore, A into B intersection A into C is an empty set. So now by observing the equation 1 and 2, both are resulting to this an empty set. Therefore, from 1 and 2 we can conclude A into B intersection C is equals to A into B intersection A into C. Hence verified. Please turn over. Let us see subsection 2. A into C is subset of B into D. A into C is 1 into 2 multiplied with this 5, 6. So we are going to get the elements 1, 5, 1, 6, 2, 5, 2, 6. B into D 1, 2, 3, 4 multiplied with the 5, 6, 7, 8. So we are going to get set of elements with the 1, 5, 1, 6, 1, 7, 1, 8, 2, 5, 2, 6, 2, 7, 2, 8, 3, 5, 3, 6, 3, 7, 3, 8, 4, 5, 4, 6, 4, 7, 4, 8. If we observe now A into C consists of this here 1, 5. 1, 5 is present here. Next 1, 6. 1, 6 is present here. 2, 5 is present in this one. Then 2, 6 is present here. So here we can easily say that A into C is subset of B into D. So we can observe that all the elements of A into C are present in B into D. Therefore, A into C is a subset of B into D. Let us see question number 8. Let A is a set with elements 1, 2 and B is a set with elements 3, 4. Write A into B. How many subsets will A into B have? List them. Solution. Given A is a set with elements 1, 2 and B is a set with elements 3, 4. Then A into B will have this number is 4. 1, A 1 into 3, 1, 4, 2, 3, 2, 4. If we observe number of elements in this one is 4. 1, 2, 3, 4. So n of A into B is 4. Number of subsets for A into B is 2 power m, where m is the number of elements in AB. So we know that number of elements in A and B is 4. So 2 power 4 is 16. Therefore, we have 2 power 4 subsets, that is 16 subsets. Those subsets are, first one is an empty set. Next 1, 3, 1, 4, 2, 3, 2, 4. Next combination of 1, 3 with this remaining element 1, 3, 1, 4, 1, 3, 2, 3, 1, 3, 2, 4, 1, 3, 2, 3, 1, 4, 2, 4. Next 2, 3, 2, 4. Next 3 elements of subset 1, 3, 1, 4, 2, 3. Next 1, 3, 1, 4, 2, 4, 1, 3, 2, 3, 2, 4, 1, 4, 2, 3, 2, 4. The last one is all the elements as a subset here. Let us see question number 9. If A and B are two sets such that number of elements in set A are 3 and number of elements in set B are 2. If x into 1, y into 2, y comma 2, x comma 1, y comma 2, z comma 1 is this, are in A and B. So in the product there are elements. Find A and B where x, y, z are the distinct elements. Given n of A is equals to 3 and n of B is equals to 2. And a set with elements x comma 1, y comma 2, z comma 1 are this in A into B. We know that A is a set of first elements in the ordered pair of A into B. Similarly, B is set of second elements with the ordered pair A into B. So given that n of A is 3, n of B is equals to, it is clear that A is be having this x, y, z, and b will be having this elements 1 and 2. If we observe this in the given elements here, x, y, z are the elements in this one. As these 3 elements are there, they are the different. And the second elements, we are having the only distinct elements as a 1 and 2, because already this one is repeated. So therefore B is a 1 and 2. Therefore set A is with elements x, y, z, and set B is with elements 1, 2. Let us see question number 10. The Cartesian product A into A has 9 elements, among which are found -1, 0 and 0 and 1. Find the set A and the remaining elements of A into A. Solution. Given that Cartesian product of A into A has 9 elements. So, let number of elements in A is x. Then number of elements in A into A Cartesian product will be x square. X into x is x square. It's given that n of A into A is 9 elements. Clearly this is given that there are 9 elements. Therefore, x square is equal to 9. That implies x is equal to 3. So, set A should contain 3 elements. Given that 2 elements among the 9 elements are -1 and 0 and 0 and 1. Therefore, the elements of this A are -1, 0, 1, because we are multiplying with this A with A only. So, -1 is an element of this A and 0 is also an element of A. Similarly, here 1 is there. So, 1 is also an element of A. So, therefore, the elements of set A are -1, 0, 1. Now, let us find the remaining elements. Thus, the elements of set A are -1 and 1, -1 and 0, -1 and 1, 0 and -1, 0, 0, 0 and 1, 1 -1, 1 0, 1 1. Already -1 and 0 are given here and 0 and 1 are given. Therefore, the remaining elements are -1 and 1, which are not colored. 1 -1 and 1, 0 and -1, 0 0, 1 -1, 1 0, 1 1.